Hello everyone. In this video, I am going to discuss working principle and operation of single phase transformer. Working principle and operation of single phase transformer. First, working principle. The transformer works on the principle of mutual induction. Transformer works on the principle of mutual induction, which states that when two coils are inductively coupled and if current in one coil is changed uniformly, then an EMF gets induced in the other coil. This is mutual induction. This is mutual induction. By this principle, transformer is working. Once again, mutual inductions state that when two coils are inductively coupled and when the current changes in one coil uniformly, then EMF will gets induced in the other coil. This is what mutual induction principle. Then transformer working on the principle of mutual induction. Transformer working on the principle of mutual induction. Now we draw the symbol for transformer. Generally, we are drawing this symbol of transformer like this. This is the core material of the transformer. Core of the transformer. And here the winding is connected like this. And this is primary winding and this is secondary winding. Primary winding is connected to the AC supply. Primary winding is connected to the AC supply. Primary winding is connected to the AC supply and the secondary winding is connected to the load. Secondary winding is connected to the load and this load is variable. Generally, this load is R, L and C, resistive inductive capacitor. And the supply voltage generally we are calling is V1, and because of this supply voltage, current I1 is flowing in the winding and it is coming like this. Okay, because of this current I1, there is a magnetic flux set up in the transformer core. Magnetic flux set up in the transformer core. And we are denoting by letter phi. Flux is denoted by phi. Okay, and when this flux is changing with respect to this coil, this flux is changing with respect to this coil, and the same flux is linking with secondary also, and here also flux is changing. Therefore, when flux is changing with respect to constant stationary coil, therefore EMF gets induced in the primary winding and EMF gets induced in the secondary winding. The EMF induced in the primary winding is called as self-induced EMF, and because of the same flux, EMF induced in the secondary winding is called as mutual induced EMF. EMF induced in the primary, it is denoted by E1, where E1 is nothing but self-induced EMF, and EMF induced in the secondary we are calling as E2, and E2 is nothing but mutual induced EMF. Mutual induced EMF. If in the secondary there is a voltage is present across this in the secondary, because of this induced EMF, mutual induced EMF, current I2 is flowing in the load. Current I2 is flowing in the load. When current is flowing, there is a voltage drop or terminal voltage across the load. It is V2. And then this I2 is flowing like this. And this is I2. I2 is flowing like where I2 is nothing but secondary current. And remember one thing, in primary we are denoting with 1, and secondary we are denoting with letter. Okay. And the primary winding having n1 number of turns, and the secondary winding having n2 number of turns. Secondary winding having n2 number of turns. This is the general transformer. To explain the operation of a transformer, I am considering this one. Once again, and this is the core of a transformer. Iron core it is. Generally, it is iron core. Generally, it is. This is iron core. Iron it is. Okay. V1 is nothing but primary voltage, and I1 is nothing but primary current. E1 is nothing but self-induced EMF, and N1 is nothing but number of turns in the primary winding, and this phi is nothing but magnetic flux. Magnetic magnetic flux, and because of this magnetic flux, EMF induced in the secondary, that is E2, is mutually induced EMF, and N2 is the number of turns available in the secondary, and because of E2 there is a current flowing in the load, that is I2, and because of that I2 there is a voltage V2 at the terminals of the load, and this is the simple operation of a transformer. Yeah. Then I'm explaining the operation. Yes, see here. Same whatever I'm explaining from the circuit, I'm writing here. When the primary winding of a transformer is excited by an AC supply and alternating current I1 is flowing, due to this alternating current and number of turns in the primary, due to this alternating current and number of turns in the primary, and MMF, magnetomotive force, magnetomotive force, that is N1 I1. Remember, magnetomotive force N1 I1 is produced in the primary winding. Magnetomotive force N1 I1. Generally, we are calling as MMF, produced in the primary, and this MMF act as a source. This MMF act as a source which circulates phi produced by the primary winding, produced by the alternating current I1. This the purpose of MMF is to circulate flux in the iron core. The purpose of MMF is to circulate phi in the iron core. Is this clear? Yeah, this is what I am writing. Next, due to alternating current I1, flux phi changes at primary. Flux phi changes at primary, and an EMF gets induced in the primary by Faraday's laws of electromagnetic induction is called self-induced EMF E1. Okay, I already told because of this flux EMF induced in the primary winding is called self-induced EMF that is generated by E1, and this induced EMF will opposes the primary voltage. This E1 will opposes the primary voltage V1 by Lenz law. I already told Lenz law effect opposes the cause of its production. Therefore, E1 is equal to minus N1 into d5 by dt. E1 is equal to minus N1 into d5 by dt. Here minus sign is because of Lenz law. Minus sign is because of Lenz law. Minus sign is because of Lenz law. What is Lenz law? Effect. E1 is the effect. This E1 opposes the cause of its production. Cause is nothing but V1. Is this clear? The flux phi available in the core is alternating in nature. We know that, and it links with the secondary winding also. The flux available in the iron core is linking with secondary winding also due to mutual induction principle, and EMF gets induced in the secondary winding is called mutual induced EMF. Is it clear? It's called mutual induced EMF. We are denoting with E2. Mutual induced EMF we are denoting with E2. E2 is equal to minus N2 into d5 by dt. Minus N2 into d5 by dt. Since there is no electrical connection between primary and secondary winding, the electrical energy is transferred by means of magnetic induction. This is very, very important. In a transformer, there is no electrical connection. No electrical connection between primary and secondary windings. We know that without electrical connections, there is no possibility of transfer energy, but in a transformer the two of primary winding and secondary winding are connected by magnetically. Therefore the energy is transferred by means of magnetic induction. And this is the symbol, and I already draw the symbol of transformer. Once again, this is the general symbol. Then this winding is connected to the primary AC supply, and this winding is connected to the load. This winding is connected to the load. This is V1 and this is I1, and EMF is E1 and here EMF is E2, and number of turns N1 and number of turns N2. Because of this E2, I2 current is flowing, and because of this I2, there is a voltage V2, and this is the variable load: resistive load, inductive load, capacitive load, whatever it is. There are three types of loads available in electrical, and this is, observe, primary secondary are connected magnetically. There is no electrical connection between primary and secondary winding. That's why transformer is used to transfer electrical energy by means of magnetic induction. Without electrical connection, it is going to transfer electrical energy. And this is magnetic coupling. This two line indicates magnetic coupling. Magnetic coupling between primary and secondary. And this is the operation of a transformer. And simple, I'm explaining with one line. Note, first, the operation of a transformer. When primary winding of a transformer is connected to the alternating voltage V1, and because of this alternating voltage, an alternating current I1 is flowing in the primary winding. This alternating current will sets because of this alternating current and a number of turns in the primary, which produce mmf, that is N1 into I1, and this mmf circulates flux in the iron core. Because of this flux is linking to the primary and both primary and secondary. Because of this flux, there is a EMF induced in the primary secondary. That EMF is called E1 and E2. And what is E1? Self-induced EMF. And what is E2? Mutual. What is meant by this V1? Alternating voltage. Alternating voltage is applied to the primary. Because of this alternating voltage, alternating current, alternating current, alternating current is flowing. Because of this alternating current, a number of turns available in the primary, which creates MMF, magnetomotive force. Magnetomotive force. Magnetomotive force. This force, generally in electrical, there is a EMF, electromotive force, which force to which force the current flowing in the electrical circuit. And same like that, mmf, magnetomotive force, which force flux flowing in the magnetic circuit. Flux flowing in the magnetic circuit. This fly is nothing but magnetic flux. This flux is linking with both primary and secondary. And it links both primary and secondary. Both primary and secondary. Because of this flux linking with both primary secondary, EMF gets induced in the primary winding and EMF gets induced in the secondary winding. The EMF induced in the primary winding is called self-induced EMF. Self-induced EMF. The EMF induced in the secondary is called mutually induced EMF. Mutually induced EMF. This is the operation of a transformer. Primary alternating voltage, alternating current, MMF sets in the iron core, primary, and which force to move the flux in the iron. This flux is linking with both primary secondary. Because of this flux, EMF gets induced in the primary secondary. This is the operation of a transformer. Thank you.